All right, it's recording now.
Okay. I do have a question though. It's just this is like off topic, but within the same within the pharmaceutical market or whatever. Uh Now, when we are measuring a drug,
Yeah.
we're trying to determine if a drug is in a patient's body.
Yes.
Uh I know it said something in the lecture. Obviously, it secretes out the urine. However, now that's how we can test through the plasma, through the blood plasma, and we can also test through the urine. Is that what we're looking for when we do these calculations? I just want to
You
have
want
some.
a bigger picture is what no,
Yeah.
what we're doing with these calculations is we're figuring the whole body's ability to clear the drug. When we measure in the urine, the you can when you're measuring looking for unchanged drug in the urine, what that means is if you give, acetaminophen, for example, Tylenol, right? And you want to measure how much actual acetaminophen, unmetabolized, unchanged, shows up in the urine. That tells you the amount, and then you can figure out the percentage of that dose that's eliminated by the kidneys versus that's been changed, metabolized, changed into something new that's no longer acetaminophen, but it might be, the
Mm.
glucuronide of the acetaminophen that and that is cleared by the liver, not by the kidneys. Does that make sense?
Yes. So it's basically, is it like basically a chain, like, because obviously the drug outside the body is not the drug inside the body. It's changing inside,
We're
right?
getting rid of it. Yeah. So
Okay.
remember, as soon as the drug gets into the body is getting rid of it, right? And it's kind of curious, at least I thought it was curious to think that most drugs, in order to get absorbed, if you give them orally, most drugs get absorbed have to be pretty lipophilic to get through all those membranes and move along the way they need to be. It can't be real hydrophilic. Do you know what I mean by that? Hydrophilic versus lipophilic, right? But in order to get removed in the urine, what is the urine? It's water, isn't it? It's not fat. So the drug has to be changed into a more hydrophilic form in order to go out in the urine. So that's why a lot of drugs are metabolized. They go from a more hydrophilic, or I'm sorry, a more lipophilic form, and then you metabolize them so they're more hydrophilic so they can be removed by the kidneys. But what's showing up in the urine is not the parent drug, it's the metabolite. Does that make sense?
Yeah, it does. Hmm.
So it's a really good question to ask. I hope I answered it, but this
Good.
this is looking at what happens to the parent drug right now. We're not doing any metabolite kinetics right now.
Okay.
We're just saying, and we know 71% of it shows up in the urine unchanged because Dr. Basu told you that. So 71% is showing up in the urine, which means it's cleared by the kidneys. The remaining 29% is probably cleared by the liver, is probably metabolized. Does that make sense?
Yes, ma'am.
So we've got part of this solved. We know K, and we know K is equal to clearance times volume. So, and we want to figure out clearance, don't we?
Yes,
That's
that
what
was
this
the whole
question
question.
asked,
Yes.
remember. So, what do we need to figure out? We know K, we now need to figure out volume.
Oh no.
That's
Yay.
easy. It's easy. With an IV bolus, it's super, super easy.
I mean, because volume is always the measurement is usually in liters, right? Or milliliters.
Correct. Now think about what we're doing when we give an IV bolus and picture this as your person. So here's your person,
Mhm.
okay? They've got a cute little face here and think of them as a beaker. When you give an IV bolus, you shoot the dose in there. So we shot 80 milligrams in there, didn't we?
Yep.
And we assume it's a one compartment model. So anywhere we test in the body immediately is going to be all mixed the same. It's all going to be the same concentration wherever we test. That's what a one compartment tells you. Is that probably what's happening? No, but that's okay. We're using that as our model here. Okay. So if we put 80 milligrams in there and we sample it and know that we have X milligrams per liter in that fluid, we can determine the volume, can't we? Because
Yes.
concentration, I wish I could write better.
It's okay. I'm visualizing what.
Concentration is equal to amount per volume, right? And if our amount is 80 milligrams and we know whatever the concentration is, we can figure out the volume, can't we?
Yes.
So now what we need to do is we need to figure out what this concentration is here at time zero, because that's our concentration before it starts to get eliminated. That's the concentration that we need for this part of the equation. We know the dose, we sample, we figure out the concentration, and then we can solve the volume. We put the volume back in over here, and then we can solve for clearance, can't we?
Yes. So here's my question. Just
Mhm.
think I'm a little confused, but I think I'm
Okay.
there. So the volume would be the concentration. Would it be any of the well, you said it will be at zero,
It
right?
has to be at zero, right? Because once we start traveling down here, then this is going to start to be eliminated and it won't represent our 80 mil. It's got to be right when it's given before it starts to get eliminated, right?
Yes.
That's why doing it with an IV bolus is pretty easy, because it's just going to be your concentration at time zero that you need to figure it out. Just like, remember when we talked about determining a loading dose?
Yes.
A loading dose is just, you know, again, you figure out the amount you want. If you know the volume and know the concentration you want to be, you just figure out the amount you're going to give. With an IV bolus, it's simple. But what's not simple is that we're going to have to back extrapolate. So it's going to be a little bit more than 10.5 milligrams per liter, right? Is what this concentration is going to be at time zero, right?
Yes.
So how do we figure out that concentration at time zero?
Wouldn't it just be zero?
No, because we're given an IV bolus. It's going to be this concentration here that
Oh,
we have to figure out. Okay.
okay.
So we can use this equation if you want, this same equation. Or what we can do is use a rearrangement of that equation, which is, I should use Dr. Basu's equation sheet because I don't want to mess you up.
I mean, it's best to know both just so I can figure out
Okay.
my own.
So I use this equation. It's just easier for me, but I'll show you the one that he uses.
Yeah, I think he placed one under the correct answer for feedback too.
Okay.
I got it for the total body clearance. That what we're look. I don't think that's what we're looking for, is it?
No, we're doing a couple steps before we get there.
Yeah.
Okay.
Okay.
But this is answering all his other questions on the homework, right? So,
Mhm.
because each question gives you a little pieces part of this. So, what do we know? Well, we know that the concentration at time 0.25, whoops, the concentration of 0.25 is 10.5, right? And we want to know what it's going to be at zero. So our time, our concentration at time zero is our unknown here, right?
Oh,
And what we do know is at time t, the concentration is 10.5 milligrams per liter, yes?
yes.
Now, what's the K? Well, we've just figured out the K.
Which was a negative 0.19.
The K is 0.198, right? Per hour. Sorry, this is so messy.
No, that's okay.
Messy, 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 messy.
Math is
My
messy.
little beaker girl. We'll erase her. And what's the time difference between what we know and what we want to know, Jordan?
Say it one more time.
Huh?
Can you say it one more time?
What's the time difference between this 10.5 that we know and the concentration at time zero that we want to know?
I'm not sure. to be
Look at
honest.
the, look at this drawing we just did. What's the time here? 0.25
Oh,
hours, right?
two
So
point
the difference between these two is what?
the
From time zero
25
to point,
minutes.
well, no, it's 0.25 hours, which is actually 15 minutes, right? It's a
Oh, it
quarter of an
definitely
hour.
is 15 minutes. You're
So
right.
it's going to be 0.25, but we're going to stay in hours because this is in hours. We want to be able to cancel those.
Okay.
All right, so this is one, just so. So now we have to solve for this number. So we have to multiply these two together and raise it to an E. Do you follow what I did there, Jordan? That's important.
Yeah, I can't. I don't know. Something's in the. Oh, that's me in the way. Okay, hold on.
What's in the way?
It's a drawing thing in a way. Oh, I can draw on here with you. Oh,
Yeah.
I didn't know that. Um, what is this right here? What is this? I can't
Wait,
see.
this, this right here. Wait a minute.
Yeah, I just drew an arrow.
Do it again, because I didn't see your drawing, which there's so much stuff on this page.
I just drew an arrow here. I don't know what
On the
this.
H, that's an hour, that's per hour, because that's our units.
Okay, I
This
couldn't
is the
see it.
K, right? I'm gonna change my color, so I'm going in a different color than you.
Can you move it? Do you mind moving it
You can
over?
move it, you move it
Again?
to where you want it.
Oh, this is okay. Hold on. I don't know how to move this thing. I want to put it somewhere else. Okay. Oh, okay. Okay, I can see it now. We can
Sorry
continue.
about that.
It's okay.
So this is our K. This is our time difference between, so what we want to know is this point, and we know this point, right? So you can see the time difference is 0.25 hours, right? And we know this is 10.5, even though you probably can't read that. But that's what you gave me for data, right?
Mhm.
So if we multiply 0.198 times 0.25 and raise that to the E, negative of that,
So, and so with the number that I have,
what'd you get?
I have negative 0.0495.
Wait, what's that number? These two multiplied together?
Negative, oh, wait a minute. Hold on. Negative one. Draco, you have to move and get off my paper. Sorry. Okay. Um, so K is equal to 0.198. And I'm multiplying that by 0.25,
Yep,
correct?
correct.
Yeah, I have a negative 0.0495.
I don't know. I didn't do that.
I,
Yeah,
I, I
it's
might have to,
negative 0.0495. That's what I got too. Good.
and can you explain exactly this uh one more time? The formula for
Sure.
this is
It's
is
actually, Jordan, if you want to know the truth, it's just a rearrangement of this equation here.
okay.
We could do the same thing here. We could say K, which we know is 0.198 negative, is equal to natural log C2, and C2 in this case is going to be 10.5, right?
Mhm.
Minus natural log C1, which we're trying to figure out. Are you with me?
Yes. Okay, that area
The
I was confused.
time, which is 0.25 hours, yes?
Yes. Now, do you
Hours.
mind give can I just do this? I just want to
You
make
do.
sure.
Yep.
Okay. So,
I've come up with what my answer is for C0. Let me know when you come up with what that is.
okay, so it's K K equals C2 minus C1, or I'm sorry, log C2 natural.
I don't
Nat
know. I don't know. I can't listen and know what you're
it's okay.
You're
It's
gonna have to
fine.
write it out for me, I think.
It's fine. I'll
All right.
give me 1 second.
Let's see if we get the same answer and then we'll be
Okay. T equals to, so if K is equal to negative 0.198, and we are already used the concentration natural log, and that is given to be 10 at 0.25, it would be 10.5, and then we're trying to determine this number, and then the time will be 0.25. And we're looking for this. Excuse me. Oh, you did it. Okay, I see how you did it. You did it a lot simpler than how I was about to do it.
but can you see why they're the same? It's all the same equation. It's just arranged
Yeah,
differently.
it's just the range, yeah.
And that's why actually I use this one mostly because I think it's the easiest way to calculate. But, I want you to realize it's just rise over run. It's just a rearrangement of rise over run,
Oh, okay.
right?
Mm-hmm.
It's the natural log that screws everything up.
I know, and I was doing the
Don't let it intimidate you. You're bigger than natural logs. You can do it.
it's just when the put it in a calculator is like it's so
You
it's
got
like
to learn how to put it into a calculator.
I know. And I do. I know how to, but sometimes you
But
get
you might be doing it inefficiently.
yeah.
I don't write any numbers down. I just keep doing in my calculator, flipping things and putting, you know what I mean?
But
Because when
you know what helps me too? I know we're not supposed to use these ones on the test, but after I complete like everything, I'll use the slope because I know that you said something about the slope, and the graphing calculator can give me the reactions that I need to see visually when I
yeah,
place them in the calculator.
good idea. But you can't do
So
it on a test.
can't
But
do it on the
yeah, it's a
test,
good idea.
but it's great to know.
Because
So
it
I
is just a slope. Yeah.
yeah, but yeah, okay.
Smart of you. That's smart of you.
I'm just trying to find better and efficient ways to study and understand and not.
Yes.
All
And I
right.
think you're doing that. Good.
Okay, so I'm sorry. Give me 1 second. I'm trying to determine that. So we gotta get 0 point, okay, negative 0.198 times 0. Oh, oh, because you're getting it on that side. I got the same answer. I got the same 0.0495 when I put it on that side. But I still have that log left, and I think that was confusing me. Can I show you? Okay, I'm gonna place it on here.
Sure.
That'll be better. Okay. So if I did not use your way, um, we have K. We want a prettier color. We're gonna use red because red stands for blood. Okay, K is equal. Oh, this is terrible. K is equal to negative 0.198.
8 per hour. Hmm.
Definitely units. Jordan, don't forget the units. My professor always used to tell me that. Don't forget the units. Okay, so since I have K, I know that here we are. Oh man, can you understand this? K equals The natural log. This is really difficult. Oh my goodness. How do you do this? I commend you. Mm,
It's practice, my friend.
yeah. Minus. It's minus natural natural log. I guess I could just make a concentration one.
What'd you get for the concentration?
I guess I didn't determine that. That's what I'm determining, right?
Okay, yep, you're still working. Sorry, I'm just
I understand. You're following along. I'm following along too. I'm looking for this, right?
what? Yeah,
This
you're
is the
looking for the
concentration.
C0. You're looking for either the
Oh, so it'll be C0, not C1.
well, depends on which equation we're working on here. So, whoops. How do I? We're looking at, forget it. I don't know. I gotta erase that. I thought I was being helpful, but I think I'm not. Okay. Um, why won't it erase? Okay. Well, we're looking for either the C0 here, which is C0 here. We're really just looking for this point, right? Which is either C0 in this equation or C1. We could call this C1 and C2, or we could call over here, oops. We could call this one C2 and C1. We're looking for this number here, right? We could
Yep.
call this 0 and 1. It's just relative to each other. Okay, we can call them whatever. We could call them 5 and 6. It doesn't matter. Just to
Okay.
know that which one came before the other. Okay, need to
Okay.
make sure that it's in the right order. So if this is C0 and this over here is C1, you have to make sure C0 happened before C1.
Or yeah.
Same thing with
Okay.
C1 and C2. They're the same thing. I just labeled them differently on these equations. So, which
Yeah.
is confusing. I
But it
understand.
makes sense. I'd rather do it that way because when you see it on the graph, like at zero at this concentration, it's 10.5. That will
Mhm.
be one. And okay.
And
I
just
feel
so
like
you know, too, it's important to know that in this equation, as it is in this equation, just like in this equation, C0 doesn't have to happen at time 0. It could happen at time 10 minutes and this one, but this one has to come after that.
okay.
All right. And same thing here. This one has to come second. This is a C2 minus a C1. So this one could be C1 minus C0, whatever you want to do, right? Just realize this one has to come first in this equation, this one first, and this one second. And in this case, this one second and this one first.
Okay.
Just keep that straight.
Okay.
So let me know what you come up with for the C0 or the C1 or whatever. What do you come up with for this concentration here, which is what we're trying to figure out?
Okay. This is so fun.
Well, I'm hoping it's helping you.
It is. It's just so hard. I don't
It's
even
not
make
that hard. You can do this.
but not this. This is not hard. I'm saying like writing on this little pad thing. So
Yeah,
this is
that's
supposed to
hard.
be
That's
this
hard. I
is
wish you were in here in my office and we could just write on
it's
whiteboards or
okay.
paper.
I told uh Dr. Shepherd that I was gonna get
Yes, I
a
used to have
whiteboard
a
for next
big
year.
old whiteboard in my office that's all we did was stand there and I'd have people putting stuff on the board. But now we have these little whiteboards like what
These
you have.
little I had to buy a new one because I don't know. I don't know. My son probably took it, but I just went to Dollar Store to buy another one. But
They're fun.
they are, but when I was in community college a long time ago, I used to make little study groups and we would rent out the library and we would have the whole room.
Yeah, that's
And
great. It's
I
fun to
like
learn
it.
that way.
I'm trying to find new ways to study. Oh, gosh. Okay. So I see what you mean when we times this to over here, and that's where I got uh z- n- negatives. That's an equal sign if you're following my little drift here. Wait, did I get a negative number? I just want to make sure I did this correctly. I did get a negative number. That's very important. 0, 4, 9, 5. So the thing is, when I got to, I don't want to. What am I doing when I get here with this natural log and the 10.5, 10 point?
Which equation? Okay.
Hold on. I'm a,
Will you just write out what you're doing right here so I can see?
can you see it where I'm at? Where
Wait, hang
I'm
on.
over on the screen.
Ah, that's why I couldn't see you. Okay, next. All right.
uh, so
Yes, good.
I
Yes.
have this, but I don't know what am I doing here?
Okay. So, you're gonna have to take raise everything to e to the x, I believe.
Okay,
So,
I get it. I get it. Okay. That's exactly so this is
or what
I
happens if I have to think about this because I'm not used to solving it this way.
yeah. Um, because the way that Dr. Basu did it, he did it kind of similar to how I'm doing it in a sense, but I don't know. I feel like I got lost in translation somewhere because my math, the way I think about it, may be a little different. Because in order for me to understand what I'm doing and to figure out what units I'm using and just to figure
Mhm.
out the equation all in general and to understand, I just have to make sure I'm doing the math right.
Right, right, right. And the algebra, actually, absolutely.
So, let's see. All right, let's do this, and then we can both see what we have. Would that be okay?
Yeah, um, I'm just asking Chat GPT because I don't want to tell you the wrong thing.
It's okay. I'm picking your brain a little bit.
That's okay. That's my job.
So so since that's subtracting, we gotta get that by 12. Let's see. So the calculator will tell me if it's an error or not. Okay.
All right, so here's what the way you solve this.
Did you get 2.3 or no? Oh.
Well, for the concentration,
Mm-hmm.
well, if we look at the graph, Jordan, what do we know that the number has to be? We know it has to be larger than what?
0, right?
Well, yeah, but I mean, what's it got to be larger than? It's got to be larger than
Oh,
10.5, doesn't
10.5.
it? It's got to
Yeah.
be larger than 10.5. So here's what we do. We can say that if we take that when you have two natural logs minus like this, we can change this to, let me see, erase that, 0.0495 is equal to natural log 10.5 divided by C1. So we can simplify that way, okay? And then if we take the exponent, this is 0.0. Then we put everything to the e is 0.0495 0.4. Let me just move this a little bit. Well, I thought I could. Maybe it won't let me. There we go. Okay. 0.495 is equal to, and we raise that to the E, we'll have 10.5 divided by C1. So what's E to the negative?
I forgot the negative.
E to the negative 0.4. Do you follow me?
Yeah, you said 0.4 or
It's 0.04, whatever. Yes,
Okay.
0.04. So it's going to be E raised to the E raised to the point. Oops, that's not right.
Is it negative point? I'm at negative.
Clear. Okay, 0.0495 minus raised to the E, right? What I got for that is 0.9517 or something like that.
Point
Is
nine.
that what you got?
Yes, 0.951705158. Yep.
So then what we have to do is that C1 is going to be equal to 10.5 divided by 0.9517, right? If we do our algebra, right?
Mm-hmm.
So then we just divide it by 10.5. Whoops.
10.5 divided by
And I got 11.03. Is that what you got?
Mm-hmm.
Does that make sense?
Yeah.
Yeah, it makes perfect sense because that's the it's bigger than 10.5. We wouldn't expect it to be a lot bigger because it's only 15 minutes, right? So this number here now, we now know, which is important, is 11.03 milligrams per liter, yes?
Milligrams per liter. Yep. Because that's
You
the
good?
Mm-hmm.
So now we were trying to figure that out so that we could figure out the volume. We still don't know the volume. How do we figure out the volume? Well, we know that any concentration is amount per volume. We know that we gave him 80 milligrams of drug, yes?
Mm-hmm.
And that the resulting concentration was what?
11.033 milligrams.
Milligrams per liter, yes? And now we need to solve for volume, and our volume is going to be equal to 80 milligrams divided by 11.03 milligrams per liter, and then we'll end up with liters, which is what we want. So that makes sense, right? And I got
I'm sorry, give me some.
7.25.
Yeah, I'm just taking some time to process.
Okay.
Okay. Concentration, this amount per liter, you have 80 milligrams. Okay.
So is that what you got?
I didn't calculate this
Okay,
part.
you go ahead and calculate it. Make sure you got the same thing.
I have 7.25, and that was the answer that I got.
And that's liter, right?
Yes. Well,
That
you know
makes
what?
sense.
I did place the whole number, the whole 11.03.
Good. So it's a little different. Yeah, it's
Yeah.
good.
But
All right.
the actual answer that I got on here is 7.62, but I was really taking my time and I wasn't I got it, but
Shouldn't
like
be that different.
it's not that well here I got 7.62. So
7.6?
7.62.
What'd you get for this number again? That doesn't sound right to
But the
me.
11 point. See, okay, so let me just see if I put 80 divided by, hold on, 80 divided by 11.03. Oh wow. So why did I don't know. I
I don't
should have.
know what you did, but it wasn't right.
I mean, it says on here that it's right, but I got the same answer as you with the calculator, but on
Okay.
the actual question,
Okay.
maybe it's rounded. I don't know. But
But you
yeah,
didn't round.
I have 7.25 for my calculator, but my
That's
answer.
what it should be.
Okay.
So now that we know volume, remember we're doing all these steps to try to get renal clearance, right?
Mhm.
So now we know that I'm sorry, we know that K is equal to clearance over volume. So now we know we can put in
You have
for
K
our
and
volume,
oh,
we can put 7.25 liters.
7.25 liters, and then K would be
And then for K, what's K?
0 point, what, negative 0
No,
point.
it's not, K is not negative. Sorry. The slope is negative, but here we want to put
Oh,
in,
K is a negative. Okay,
we
so
don't want to get a negative clearance, right? So,
we don't want to kill the patient.
nope, we do not. Per
So
hour.
0.198 is K.
Mm-hmm.
Our volume is 7.25 liters,
Mm-hmm.
and we're looking for the clearance. So, of
And what'd
course,
you get?
that would be uh, times 7.25. I have 1.4355.
What I got. So now that's our total body clearance, right?
That's the total body clearance. Okay.
And then to get renal clearance, we take 71% of that.
Oh, that's how you get that step. Okay. And that's okay, the 71. So 71% of the
Yep.
1.4355.
Yep.
71%. Okay, so that's 0 point.
That's what we started out right way back here. Right? That's where we was our first question. So I got renal clearance to be 1.02 liters per hour. Is that what you got?
Hold on. I times it by 0.1, yeah, 0.71. I got 1.019.
Yep.
So
So I,
one, yep, 0.2 liters per hour for
did you
the
follow all that?
renal clearance. Um, yeah, a little. I gotta practice a little more because the quiz is on well, this due Sunday. I think if
Yep.
I do a couple equations, um, I can understand it because I gotta figure out my own way, but be
Yep.
also be right.
Yep.
Hmm.
I have an 11 o'clock, so I'm gonna have to say goodbye, but I'll post this. I'll send this video to you. I have to put it through YouTube and all that. It'll take me a little bit, but
All
I'll
right,
get it
take
to you.
your time.
Was
Thank you.
that helpful?
Yes, it was. Thank you so much for meeting with
Thank
me.
you for working so hard. And I expect 100 on your quiz.
100. I'll try. Thank you.
You're welcome. See ya. Maybe I'll see you at 4, but that'll be posted too. Okay.
You will see me at 4.
Okay, great.
All right.
Bye, Jordan. See ya.
Bye.